So yeah, hi, I'm Sören. I'm front-end engineer for the Nimiq blockchain project. And as Pascal said, we are JavaScript-based browser first. So all our amazing APIs work in the browser. And it's actually very quick and very easy to get started. So I will show you exactly that. And I think it would be best if you just work together with me and we do it at the same time, because all we need is a website, is an HTML file, and an editor, well, and a browser to then display it. But all right. So all I'm going to talk about, all I'm showing you today, is basically the first two tutorials on the Nimiq Dev tutorials Dev Center, and also the Getting Started page of the Hub docs. The Hub, just to remind you, is the interface that sits between the key guard and the apps they want to interact with keys. So the Hub is the third-party interface to interact with the users' keys in the browser, or in their browser, basically. So yeah, like I said, everything is visible via the Nimiq.dev domain. And to get started, I will just create a new HTML page. Just gonna store that in that nice folder over there, BDLT.html. There it is. And I'm just gonna start with a very basic, press tab actually, there we go, HTML file. And gonna call that BDLT rocks. And then the only thing we need to get started with Nimiq is a script tag that fetches the Nimiq script from the CDN, which is https://cdn.nimiq.com/ using version 1.5, which just came out 2 weeks ago, Pascal? 1 week ago, 2 weeks ago, which now includes the new core API, the new core client API, which makes everything very much simpler. So just Nimiq.js from that domain. And then we have a new script tag to do our coding. Right. The very first thing will be to have a variable that holds the references to what we're going to do today. So I'm just going to instantiate a Nimiq object here. Note the lowercase, well, I can name this anything I want, but the uppercase Nimiq is what is the global variable that we get from the Nimiq library, so I can't use that. So I'm just going to use the lowercase one for all local objects here. Okay, so when we start up Nimiq library and the Nimiq network, we get a callback. We are able to provide a callback to that. So I'm going to just create a function here that we use as a callback. And then we're going to pass this in to Nimiq init, and that is the callback. Right. So far that doesn't do anything because we haven't told them to do anything. So the first thing that we have to do, it's a 3-step process. So getting started, the first thing, the only thing that you need to do to connect to Nimiq is 3 lines, which is basically 2 lines, but we're going to split it up into 3 lines because that makes it simpler. The first thing we have to do is tell it which network we're using. We have currently we have the dev. Do we still have the devnet?
It's just fine.
We have the testnet and the mainnet. So we're going to use the testnet here because it makes everything simpler. So I'm just going to instantiate the Genesis config for the testnet. Step 1. Step 2 is creating a Nimiq client configuration builder. So our builder is going to be the Nimiq client configuration builder. And then the last step is to create a client from this configuration, which we are going to store in our Nimiq object for use. So we have a Nimiq client, and that is just simply the builder, and then we're going to do instantiate client. Right, I'm saving this. I'm just checking here, and then opening the console, because for now we're only going to see it in the console. And then if I go to this page, I will see the Nimiq library loading. It's loading, actually, it's downloading WASM, so WebAssembly in the background for its workers. And then down here already we see base consensus, synced with all connected peers, 3, consensus established. We just connected to the Nimiq blockchain. Peer-to-peer, without middleman, without any trusted third parties. We are directly connected to 3 peers in the testnet, in the Nimiq testnet live right now. The few seconds that you saw that it takes now is actually also pretty new, which is our new so-called Pico consensus, which is a even shorter version of the Nano consensus, which was an even shorter version of the Light consensus. So we are already 3 improvements in right now already. So the Pico consensus connects to peers via the seed nodes and just fetches basically the Nano client that we had before fetched the headers already of the last couple blocks, and was also pretty fast already. It took 10 to 12 seconds on a stable connection and around 40 seconds on a mobile connection, which was a bit spotty. So, but now the Pico consensus is even faster. As you saw, it just took a couple seconds. If I refresh this page, it instantiating the WebAssembly workers, and there we have it. That's the consensus. Right. But we want to do something. We want to do a little bit more, right? We want to visualize this change, not just in the console for us nerds, but also to the user on the website. So I'm going to create a few DOM elements to hold references to display the updates in. So first it's going to be the consensus state, and we're going to put that here, consensus. It's going to be in there, and I'm just going to put loading there as a placeholder until we fill it with data, so that will be that one. Right. The Nimiq client allows us to give it listeners, for example, a consensus listener. So I'm going to create a function, which is going to be the callback to this listener, on consensus changed. And this is actually receiving the state as a string, as a parameter to that callback. And then I'm just going to put that into the consensus span here. For that, I'm just quickly going to create a little helper function, which is going to be very much jQuery, not supported, but jQuery. You know what I mean? As following the example of jQuery back then, so it's just going to return us our node document get element by ID of the ID. Right. So if I go here, and I'm just gonna consensus, and I'm gonna put the text content state in there. So I'm just writing the state that the Nimiq client is giving me back in there. Oh wait, it's not giving me back anything yet. I have to tell it to give me back, so I'm going to add a consensus listener now to the client. So this is the, let me lie, hold on, cheating, yeah, it's actually called add consensus listener, and we pass it the on consensus changed callback. And if I refresh this now, I will hopefully not get a JavaScript error, but I actually did get a JavaScript error. Oh, yeah, sure. It's called the add consensus changed listener. There we go. And then we see it updates our loading field to established after a very quick, very visible syncing in the middle. Try again, loading, syncing established. There we go. So that's the first step. We have now a visual representation of the consensus state. The next thing is, I would like to know how many peers I'm actually connected to, how many I'm connected to, how much data I am receiving, and how much data I'm sending. And for that, I can use actually a script step. Right. First, before we know how many peeps we are connected to, let's see what the actual current height of the blockchain is. Right. So the client also takes a onHeadChanged callback, onHeadChanged listener. So the head change means the head of the blockchain, the top of the blockchain changed. So I'm going to create an onHeadChanged callback here. OnHeadChanged. And in that, I'm going to pull the latest height. So this is going to be an async function actually. Async. And the height is going to be an await of the Nimiq client get head height. And then when we have this, I'm just going to put this into a new DOM element here. Height, span, ID, height. Well, we are there. So height, text content equals height. If I refresh the page now, I will get an instance step. Oh, I'm always forgetting to actually add the listener. To actually tell the client about the listener. So Nimiq client add head changed listener. And now we try this again. And then when it's established and it's calling the head change listener for the first time, we actually get the current blockchain height of the testnet, which is currently sitting at 636,217. And as Pascal also said, we have a block time of about an average 1 minute. So roughly every minute, this will change automatically because the head change listener is getting called by the client. Right. Back to the network information. Like how many peers are we connected to, how much data are we sending, and how much data are we receiving. For that, we will use another handler function, which is also going to be async, and it's going to be called get network stats. And what this will do when it's triggered, it will get a few variables from a function result, which are called get. Oh wait, sorry. I have to look this up. Sorry. Total peer count. There we are. Okay, total peer count, bytes sent, and bytes received. And they are coming from an await of the Nimiq client.network.get statistics. Right. So we will get the total peer count that we're currently connected to, we will get the byte sent and the byte received. And to put them somewhere in the interface, I'm going to fake a break here. And then I have a div called peers, where I'm going to put the peers in. And I'm going to have the send and receive stats here. And then we're just going to write the variables into the DOM. So for the peers, we're going to text content the total peer count. For the sent, same. And for the received, the same. Let's see if this works. Right. First of all, we are first going to actually call this function in here, And because we want updates regularly and not just when anything happens on the blockchain, we're going to add an interval, document set interval. This is the, it's actually just called set interval. And we're passing it the get network stats, and we're going to call it every second. And if I refresh the page now, I hopefully get data here and not a JavaScript error. Oh, actually it worked. Right. So we see it here. I'm actually connected to 8 peers right now on the testnet. Some of them might be you if you're running this at the same time. I have sent so far 8 kilobytes of data, and I received so far 6 kilobytes of data. And just to run this again, for establishing consensus, let's see, there it is. Actually just took 3 kilobytes, and now we're up to 7. So around 7, under 10 kilobytes to establish consensus with the Pico client, connecting to 8 peers. 8 peer-to-peer, non-custodial, well, not non-custodial, but non-middleman peers. Right, so this is already pretty cool. I'm going to add a very little style here to differentiate between the labels and the content. So we're just going to make every span font weight bold and give it a nice color. No. I actually like Rebecca purple very much. So let's see how that looks. Okay, cool. Consensus established. We're by now 3 blocks further. Cool. Oh, sorry. Cool. Right. So now we have a node in the browser. We have a consensus. We are connected to peers. We're sending and receiving data via the network. This is all still the core JavaScript library which Pascal helped building. And me as a front-end engineer, our team built the Nimiq Hub. And to now actually do anything with the network in our browser, we actually want to interact with addresses. We want to send and receive Nimiq. We want to create addresses. We want to manage our addresses, because that's what a wallet is for. So as a next step, I'm actually going to add our second library, the Hub API, the Hub library, into our little app. And for that, I'm going to the Nimiq dev/hub docs, which redirects me to the Nimiq Hub API documentation. And there, under the installation, in the installation section, I see the script that I can just copy and paste, which is pulling the latest standalone Hub API from a NPM mirror, from an NPM CDN. And just go back here and go back over to usage. It actually tells me it's that simple to start with a Hub API. I'm just going to instantiate an object, Hub API, new Hub API, which is the global object introduced by our script above, and I'm telling it to connect to the network, telling it to connect to the testnet hub. So hub.nimiq-testnet.com. For the mainnet, we would use just hub.nimiq.com. Okay. And then I already have a working Nimiq Hub connection. Right, so what we're going to do. First of all, we're going to ask the user for one of their addresses that we are then going to display here and show their balances, and then allow them to receive and to send a transaction with that address through the Nimiq Hub. So I'm going to add a new section in our app, which is going to be the address that the user selected, and below that we're going to put the balance of that address. Right. Oh, and for the user to interact with the hub, we actually need them to somewhere, which then prompts them to select the address. So I'm going to add a button here. Button select, and that ID is called the select button. So for this select button, we're going to add a click listener, add event listener click, and the callback is going to be that we are calling the Nimiq Hub. The Nimiq Hub is going to open as a pop-up. By default, it can also be configured to open as a redirect, but we're just going to use a default pop-up case, and pop-ups in browsers can only be opened within an active user action, for example, a click. So I need to directly within this click, I need to synchronously call the Hub API to open a pop-up to ask the user for their address. So I'm going to get the address by awaiting the Hub API.choose address call. The choose address call actually requires an options object with one parameter, which is the app name, to display to the user which app actually now require access. I'm just going to call this the BDLT workshop. And then after the user gave us their address, we're going to put this into the DOM, into our field that we just prepared. So the address is going to be the text content of the address field. Another little change is that the choose address call actually returns us an object which contains both the address as a string and the label. So we are just going to quickly deconstruct this result and just fetch the address from it, not the label. Right, if I call this right here, and let's see if the consensus still works. Alright, await is only valid in a async function, makes sense, so I'm going to make the click handler an async function, and hopefully I didn't forget anything else. No, that should be it. There we are. Okay. So if I now click this button, select, it opens the Nimiq Hub, the Nimiq testnet hub for me, which already has my addresses, which are currently stored there. I'm just going to select this little cutie here, the Telly Waddling Genius. And if I click this, it returns the address to my website, and I see the address here that I just selected, and the balance is currently still empty because we haven't done anything with it. Okay. Since I did this now after the consensus established, this should be fine to quickly request the balance here actually from the network. Let's see, are we doing this here? Or are we doing this in a separate? We're doing this in a separate function. Okay. So we're going to create a new function, which is also async, by the way. And we're calling that the getBalance function. And then we're passing it the address. And this function quickly does a const balance, also deconstructing of Nimiq client.get account. And the get account, let me quickly look up what I did yesterday to prepare for this. There we are. Yeah, it just takes the address. So it gets the balance from the Nimiq client. That's actually also a promise, so we await this. And then when we have the balance, we're entering it we're displaying it to the user. And last but not least, we actually need to call this function from here. So after we have the address, we're calling the getBalance function with the address as the parameter. Right, if I do this again, we have to wait for the consensus to load, otherwise it will fail because we cannot get accounts when we have no consensus. So I just select my address again, and there we go. Oops, what is this? Right, probably know Bitcoin. Bitcoin has 8 decimals. They use Satoshis, which is lots of zeros after Bitcoin, and Nimiq, similar, it uses, how much is it? 100,000, I think 100,000 lunas is 1 nim, so that's 5 zeros. So actually, these 5 zeros are the decimals. And to display this more nicely in the native nim currency, we can use a very nice helper function from the Nimiq library, which is the Nimiq policy.lunas to coins. And we're just gonna pass the balance in there. We're going to add a nim icon up here, nim writing, so we know that actually the Nimiq address, nim balance. And trying this again. Trying it again. There we go. 30 nim. Correctly converted from lunas to Nimiq. Cool. So that I don't have to select my address every time again, I'm just going to quickly store it in the browser, so it gets auto-loaded again. So I'm just going to do local storage, address is my address, and also storing it in the Nimiq object to use in our app for later. So Nimiq address is my address. I'm actually going to move this over to the get balance call, because then I can just call it directly when the website loads. So I'm going to do if local storage has an address, address, then call get balance with that address. Oh, local storage. Right, but like I said earlier, we can only do this when consensus is established, or rather when the Nimiq lib is loaded. So we are going to do this in the callback for the init function. Let's just see if it actually does what I want to. It doesn't. Alright, actually it just didn't do this part, which is still in the old function. So if I do this again, it just didn't display it to me. Now my only question is, why didn't it get the balance? Update it. Fail to retrieve accounts. Try this again. Okay, now I have cache disabled. Nope, it's still complaining. Right, so this worked yesterday. I'm going to try this for the first time. Actually, I think what I did was I moved the balance update into the on-head changed. So I only do this when consensus is established, and every time that the head of the blockchain changes, every time a new block is mined, we are going to update our balance. And here we're going to use the Nimiq address, which we stored earlier. Exactly. So now when the consensus establishes, it should also update the Nimiq balance right here. There we go, 39. Okay, cool. So we still have the consensus with the call library. We fetch the address that the user wants to use in this little wallet app from the hub. And now we are going to allow the user to actually send from here. Right. For this I'm going to create another section in our little app. I'm just using a H3 this time to mark it, send transaction. And here we're going to have a little form, not a DOM. A form, not a footer, form, there we go. And to send a transaction transaction, we need two things basically. Yeah? We need the recipient, and we need the amount to be sent. So I'm going to add an input, which is going to be the ID recipient, and I'm going to add an input, which has the ID amount. I'm going to put this both into diffs so that they don't float next to each other, and the diff, got a label in front, recipient, amount, and at least but not last but not least, a little submit button. Type submit. There we go. The form is actually also has an ID because we need to listen to the event. So this is the send to X form. And then refresh the page. I see the send transaction form right down here. Right. Little event listener for this. Send to X at event listener on form submit. We're going to use the event to stop it, prevent default, so it actually doesn't submit inside the page. And then we're going to fetch the recipient and the amount. So const recipient equals recipient field value, and the amount equals the amount field value. Cool. We can now use the hub again, the Nimiq Hub, to actually send a transaction with that address, with that user's private key for this address. So we are going to call the hub API dot sign transaction request, and we're also going to pass in our app name again, which is our BDLT workshop. But also now we require a little bit more. So first of all, we need to know, the hub needs to know the sender again. Which sender is actually sending here? So for that we have stored our Nimiq address that we selected earlier, and we can pass that in. Next, the hub also needs to know where to go to, where the funds should go to. So the recipient is the recipient that we passed, that we read out from the recipient box. The amount is actually passed as the value option, and the value is required to be passed in Luna. So we need to convert here back from Nim to Luna, so we can use the same or a similar policy function again. We just convert coins to Lunas and pass in the amount that we read out of the field. The sign transaction needs one more field, which Pascal also talked about, which is the validity. Yeah, it's a very hard word. Validity start height. Because of the replay protection, all transactions have a start point from when they are valid for roughly 2 hours. So we need to pass this in. Validity start height. And we're going to use the current blockchain height. So we are quickly fetching the blockchain height again from the hub, from the core client. Right. The fee is actually optional. We can also pass in a fee in Lunas, but in the testnet, that's pretty much 0. In the mainnet, you should at least consider 1 or 2 Lunas per byte. But so far, this should be just fine. Right. So this just signs the transaction, as Pascal said. It passes a request into the hub, then into the key guard. The user enters their password to decrypt the key. The transaction gets signed, sent back through the hub to the app, and then we want to actually do something with this signed transaction. So the transaction is actually going to be the result of this asynchronous call. And for now, I'm just going to output that to the console. Log, please. Just going to output the signed transaction here. Right, let's see if this works.
Async field.
Pardon?
Async is missing.
Async is missing again? Oh, right here, right? Yeah, you're right. Okay. Good. I need another recipient. I'm just going to quickly go into my testnet safe, where I have all my accounts, also the accounts that I have in the hub that I just shared with the app. So I'm just going to select another address here from my addresses, and I'm inputting that into the recipient field. I want to send 12 nim at the moment, so I'm submitting this, and now it opens the hub again, like I said earlier. It opens the hub, passes in the request object. I see the two transaction partners right here. This is my sender, which I selected earlier and gave to the app. This is a recipient address that I just pasted in, and here's the amount. Right, if I now enter my password for this first account and confirm the transaction, it gets signed, bam, and returned to the app. So now we said we are going to log it into the console. So right here, this is the result object. I hope you can all see this. I can make it a little bit bigger. Right, so what we get back in this object is, first of all, the transaction hash, which is this hex string over here. We get all the raw data of this transaction that is required to reconstruct this transaction from scratch. We have the recipient address, we have the sender address, we have network ID, which is 1 for testnet. We have the signature here, 46 bytes, and we have the signer public key here, 32 bytes. The validity start height is the current network height, and our value is 12 nim in Luna. Cool, so we could create a whole new transaction object from that through the Nimiq.transaction constructor, but we can also use just the serialized transaction, which we get back conveniently from the sub API call as a hex string. So we are just going to use that as a, oops, go over there. Just going to use this to send directly as is into the Nimiq client, because Nimiq client also accepts serialized transactions as hex strings. Right, so we're just going to do Nimiq client.send transaction, and we're just going to pass in the transaction. And that will then send it out to the network, to the connected nodes at that point in time. Right. Before we do that, I will add one last listener to our client to actually display to us incoming and outcoming transactions. So above the send transaction form, we will have a little new transaction output. Just a little new GX. Okay, cool. And we need another handler. No, another callback, another handler function for that. So the function is on transaction, and it gets the TX details as a parameter. And now we can just display this info to the user. We can say, in the TX span, please show me let's do it as a template string. TX from TX details. Oops, it's easier when we have autocomplete. TX details from sender to TX details from recipient of TX details, autocomplete TX details dot value nim. Right, and to have nim, naturally we need the Nimiq policy lunas to coins and pass in the TX details value. Right, so this is a very long string, so I think I can actually break that in template strings, this from to of that amount of nim. The Nimiq addresses by default are stringified to base 64, but we want the user-friendly representation, so we can just do a to user-friendly address for addresses, and that will display us the IBAN format. Okay, so this is called whenever the client detects a transaction to one of our addresses that we are subscribed to. So we are going to add this transaction listener right here, Nimiq client add transaction listener, and we pass in two things now. We pass in the onTransaction handler, and we also pass in an array of the addresses which this listener should be called for, which is in this case just one address, an array of one address, which is our Nimiq address, right here. Right. And now we will actually try this out as well by sending to this address first. I really hope I have nothing mistyped here. So I'm copying this address that I want to send to now, going back into my testnet save, I'm using another account to send to my app, and I'm sending 12 nim there for now. I'm just going to quickly sign this via the save and the keyguard, and then it's being sent out to the network by the save, and let's see if in our app it actually showed up. And so far it hasn't, which is not good, because this also worked yesterday. Which doesn't help you, I know, but it is how it is, right? Right, so what did I miss? Let me try that transaction listener. Right, I have it the wrong way around. Okay, so we need to assign the address to the Nimiq object first, before we can actually then use it. I can also here use the local storage address. Let's see again. How many confirmations? 4 already. But this will not show up anymore. Let's try this again. Send a new transaction from here to there. Another 12 nim, please. Sending. And please show. There we go. Okay. So now our app received the information about an incoming transaction from the network via its peers and via the whole network. So I have a transaction coming in from another address that I don't recognize, or which is the other address, to my own address, which is the LFMH in the end here, of 12 nim coming in. So we have I forgot actually one thing to pass into this little status right here, which is we can actually display the status as well. So the state of the transaction is stored or is passed in the txdetails.state. So let's see, this is still pending, so this should still arrive over here after we established. There we go. So the transaction is still here and its state is pending. So when this transaction will be mined, the state will, the listener will be called again, and the state will then be mined, and it will show up here. Okay, cool. Right, back to sending one more time. So I select the address to send back to again. I entered here 12 nim. Well, actually this time let's send 13. Let's see if this actually gets mined. I set 1 minute block time. We open the hub again with our hub API. I sign this with my Nimiq keyguard. and then it goes out into the network. And there we actually have an invalid transaction format, which is interesting because it's a transaction. Oh yeah, actually I cannot pass in the actual object, but the actual serialized TX that we got from the hub. Right. Still pending. Okay, cool. Let's try this again. Reload. Pass in the address that we want to send to, 13 submit this, sign again, and this time it's still not sent because I forgot forgot MI. Let's copy this from here to be safe. There we go. Typos and debugging. Now I don't have the address in my clipboard anymore. Copy it again. 13 last try. Sign. And there we go. Actually, the listener updated already. Here we see now the transaction which is outgoing from our LFMH account to the other account that I answered here as a recipient 13 and it's already been mined. If I go over to my safe, I can see this is the one that I just sent towards the app, and this is the one I just sent from the app, 13. Right. So this is very basic integration. This actually, up until the transaction monitoring and until the hub login, is actually the first two tutorials already. So tutorial 1 and 2 of the nimiq.dev/tutorial section. And the hub API integration is basically the quick start of the hub API docs. The hub can do a few more things. I can quickly go through this. So the API reference, so publicly available for third-party integration currently with the hub to interact with your users' Nimiq accounts is the checkout function, which actually works very similar to the signed transaction, although you don't need to pass it a sender because the user then selects the sender during the checkout, and you also don't need to send the transaction afterwards because the checkout already takes care of sending it. So the shops or merchants or online shops that want to integrate it don't have to send the transaction themselves. So that's all happening in the hub, and you still get back the transaction to save the hash or to save references to it, but basically the checkout is made, so you just pass in where the transaction should go, the recipient, the value of it, and that's it. And then everything is done for you. The choose address we used for the user to select an address for us for the app to use. We also have sign message, which allows the user to prove that they have the private key for an account, so they basically sign message with their private key, which can then be validated with a public key and a signature. Signed transaction we also used to send the transaction, and then also actually sign the transaction, which we then have to send ourselves. And the last step here is just a reminder that the account management is currently not yet available for third-party integration, only for the safe, because we have no good permission model so far to authorize other apps for these management tasks. Right, but these 4 methods are open to all apps, to all websites that use, well, they don't actually have to use HTTPS. You only have to use HTTPS if you want to do redirects, but for pop-ups you can use any website that can integrate the hub script. Quickly I'm also going to nimiq.dev/tutorials, which brings me to this lovely site, which is very big right now. Okay. So like I said, we currently have 5 tutorials online. The The first one is establishing consensus, which is what we did in the very first section, just 3 lines. The testnet, the network selection, the configuration builder, and then creating a client from it, and that's all you need. The second tutorial is then about blockchain events and a little bit about user interface. But the blockchain events is what we did with the consensus change listener, with the head change listener, and then also with the network statistics. And then we have three more tutorials. 3 and 4 handle creating transactions yourself. Basics 3, tutorial 3 is for basic transactions, which is a specialized transaction format in the Nimiq blockchain that reduces the bytes necessary for storage and for sending. And the 4th tutorial is the extended transactions, which can include messages, which can include extra data and text, which then costs more bytes. But they can all be created manually with the Nimiq library, with the Nimiq client library, and that's explained in tutorial 3 and 4. And then tutorial 5 is a very interesting property of the Nimiq ecosystem. You might know this, you might probably know this from Ethereum. They have little identicons, little identifiers for addresses, these little blocky identifiers. In Nimiq we actually have identicons, which are little people, basically. Where's a good screenshot? I think on the last, there's a good screenshot. There it is. So in Nimiq, we are generating these little guys, these little identicons for the addresses to help users identify misspellings or copy-paste errors, and generally easily compare addresses, for example, across the phone or across chat. Well, chat is easy because you can just copy and paste addresses, but over the phone, for example, you can just say, hey, is your address this guy in the orange, this blue guy on the orange background with the doctor's mirror on his head? And then the other guy says yes, and then it's highly unlikely that the address is still wrong. So there's not enough identicons to represent all addresses uniquely, but there's, what did you say earlier, Pascal? 140 million? 40 million? There's a lot of identicons possible, so they're very unique for each address. So yeah, tutorial 5 will go into how to integrate identicons into your app to identify addresses. And actually every tutorial has its own live demo page, so I can just go back to tutorials, Nimiq 5, and then I click up here, run the demo, and then it actually shows me the code on the left side that is currently running, and the result on the right side, and we see here that we have an identicon. We have an identicon for our address here in the demo, in this tutorial. This address sadly has 0 nym to the person, but they also have a very nice and stylized also sending transaction form, including the message format that I mentioned for the extended transactions. So these tutorials go through the whole thing, how to basically build a mini blockchain Nimiq wallet with our available core API. Okay, I will talk about the API reference. API reference, similar, every method that you see here, let's try out the signed message actually. Every message that you see here also has live examples. So this is actually the code that is required to run this, after the setup, obviously. And I can also click this button to just try it out. And I just select my account that I want to sign with. And I'm seeing here the text that the demo on this page put in for me. So it says, I like the Nimiq Hub API, which I do very much. Thank you. And if I sign this transaction, it gets signed and the result shows up here. So basically, all our documentation has very approachable, very nice live examples and direct examples of the code that you need to get started. The result here is also documented. So we have the signer address, as a string, we have the sign up public key as an U8 array or byte array, and the signature as well. And then for the signature verification, actually for signed message verification, there's also a section down here that details how actually you would do the verification in the end. So this is a running code example which you can pretty much use like this. Right. Yeah, both these libraries, both the core API and the Hub API, can be used either as script tags or as imports in module-based JavaScript. The core API naturally can also run on Node.js, on the Node.js server side. The Hub API can't because it requires the window and the user's browser. But both can be also used as module imports right here, for example, and then be bundled together with your bundles with your build system. Using redirects is also explained. It requires a few extra steps because you first need to tell the Hub API where to come back to, and then you also need to explicitly listen for the result on a redirect back to your app. But it's all explained in this lovely docs over here. Right. So by now actually we see that the transaction that we send is actually confirmed. By default, the configuration, the Nimiq core client API configuration says that after 10 transactions, after 10 blocks, it's taken as confirmed. So we also get an update after 10 blocks from the API, from the client that is then displayed here. All this is naturally configurable. That's why it's called a configuration builder. So you can actually change things in the configuration. You can add the mempool functionality so that your app also can have a mempool and fetch other people's and get to knows about other people's transactions that are going on in the network. It can have a full node, which is, like Pascal said, only really useful on the Node.js side. And depending on what features you add to the configuration, when you then call the instantiate client function, it automatically creates the version of the client that is best for you. So in this case, when we don't need anything, it's a Pico client. For the mempool, it will create a light client, and if you need a full transaction history, then it will create a full node for you. Okay, so this client was released with Nimiq 1.5 just 1 or 2 weeks ago, and will also be extended. And community feedback was already considered. For example, the network stats, for example, should be published actually actively when the network changes. So there will be updates to this in the future. And if you have any suggestions on what other info you would like from the network to work with your app, we're always very happy to hear how our code, how our APIs are used. Basically, that's what I want to show you today. We created a very basic single address wallet app here. We can like the safe is basically built on this. Our safe is basically built on this. We have a extended wallet storage in the safe and cache for the transaction, so we don't need to pull them down every time that the user opens the safe, but they are all cached locally. Their accounts are cached, their balances are cached, and then only updated when needed. But basically, this is what a safe does. It creates a consensus, creates a little client and consensus in the browser directly for the user to then interact with their Hub accounts, and allows it to send and receive transactions. Are there any questions?
Can I use it without any HTML template?
That's not a question.
So you need to use the Hub from a website.
Yes. But I want to show the user this in the WebGL.
The WebGL?
Yeah.
Yeah, sure. Well, basically in a pop-up, the Hub needs to be called an active user action, mostly clicks.
Is it possible to pop up in the WebGL? It's a canvas.
The Hub API itself is currently doesn't support iframes, so for example, or canvas itself. But basically it's a different origin. It's a different window origin, and the messaging between your app and the Hub origin, the Hub page, is done via browser post message based RPC remote procedure. Calling end.
The interaction with the user is done on the HTML.
The interaction with the user is in the Hub domain.
Okay.
So that needs to be either an iframe or the pop-up or a redirect.
So I think in iframe or embedding it in WebGL should probably not work for security reasons, so that you can't draw something on top of it and basically trick user into clicking something like that.
Yeah, I think for example the key guard is actively blocked from being embedded as an iframe.
Okay.
Via server-side hackers, security hackers. So just quickly, what you're seeing up here is the mainnet actually, which is our miner.nimiq.com browser miner, which has a very nice representation of the world and us in the middle of it, right here in Vienna, my browser, and seeing where I'm connected to. I'm actually connected to 6 peers. Apparently 4 of them don't show up because their IP address cannot be mapped currently to a location. But for example, I'm connected to the Nimiq Seed 14 here in the United Kingdom. I'm connected to the nimiqmobsys.com backbone node from some community user. And all these little dots here is, for example, this is an available browser that's currently connected to Nimiq in the Ukraine. This is a little browser, this is not a little, this is a browser currently connected from Portugal to the Nimiq network. This over here is Seed 19. This over here is another available browser in the United States, Napa. So this is actually a live representation of the network currently, and I don't know if you saw earlier, but new nodes, new locations are popping up sometimes. There's a browser in Australia currently connected. So this is all the same network, and they're all connected with each other. And each node cycles through different peers. Browsers prefer to be connected to backbone nodes because they have the full history and they are trusted a little bit more, but it can also just as well connect to other browsers. And it sometimes does.
Is there any way for people to give you feedback about the API in the system?
Sure, like we have, there's no feedback function built into the API, but we have emails, we have Telegram, we have a forum, which is actually the developer-focused location, so forum.nimiq.community. And any one of us is listening at any time for feedback, for improvements. GitHub, in the end, GitHub issues are the last resort as well. So there's lots of ways to contact and to improve and to suggest changes.
And the second point that people might be interested, if not, I know.
Yeah, sure.
So maybe you have mentioned it, but do you have some opening positions or some, some jobs that you are looking for interesting and challenging people? And, you have a lot of years.
So I can only talk for the front-end team. Pascal is probably the best to talk to for the core team and for the actual protocol level stuff. In the front-end team, we just hired another developer last month. But we're always looking for people from the community that engaged in the community, that build apps on Nimiq, which then show up on our radar and we see, that's a cool person, and let's invite them to our offices, to our location, and see if we can work together. And if somebody is getting noticed and then shows up and fits into the team model, then I was hired that way, basically. I got to know Nimiq via their first Hacker News post in July 2017, when you had the BetaNet, I think the first BetaNet live. And Nimiq, being JavaScript based, was actually my entry point into the blockchain. So I was blockchain was getting, news about blockchain were getting around the tech scene. As you know, 2017 was getting, Bitcoin was getting bigger and bigger, Ethereum as well. And I was starting to get interested in this stuff and how this new technology works. But I never had an entry to it because it was written in C, it was written in God knows what, which I didn't know because I'm a simple JavaScript developer. And Nimiq then actually being, I think, place 1 or 2 on Hacker News when I looked, and JavaScript-based blockchain, and bam, that was my entry point. I looked at the code, I understood the code mostly of the BetaNet back then. I played around with the apps that they had, and I built the first block explorer, which is still up, Nimiq.watch. That's still my little baby. And I also built a browser extension, I think, back then, which then prompted you to invite me to try out to work with you. And that's how I got hired in the first place.
Yeah, so in general, we don't have a web page with openings, but we're always looking for good people and new people. We're always deciding on a basis of case by case. So if you're interested to work with us or to work on a project with us, or whatever idea you have, you can just contact us and have a look at it. And that's how it works.
More comments?
Sorry, one more thing. I was actually asked by, I don't see it right now. We have Nimiq Community Funding Initiative, which is nimiq.com/community funding, which also links from the homepage, etc. And this actually allows you to send proposals for projects you want to work on based on Nimiq to the Nimiq funding board, and then they will vote on, or the board then considers these proposals, and they meet every month, every 2 months to consider the proposals. All the details are on this page, nimiq.com/community funding, and you can request funds for spreading the word for NIM, you can request funds for development costs and stuff.
Yeah, also for research it works as well, and the nice thing is, so basically we set aside these funds, but the decisions on which project should be funded or not is not only made by us. But
exactly, yeah, it's a community funding board. The board is made up of 3 team members and 3 community members, and every proposal is made public to the community, so we get feedback from them, and then the board votes on which projects to fund and how much. Well, the proposal already includes expected or requested amounts of funding, and then the board decides how to go about that.
Thank you guys for that. It's really nice. Actually, I see there that you have 9 active projects and 4 finalized projects. Is it possible to see these projects, or would that type of projects?
They are not listed here yet, but we are publishing after regularly the community project funding reports are published. So this is actually number 4 and number 5. The other ones are on Medium, which we used earlier as a blogging platform. And this was elections of the new board just last month, 2 months ago now. And in here, in these blog posts, the projects that are funded are listed. So this is actually a list of all the ones listed so far that has been considered and funded so far. And then this lists the different projects that requested funding and got funded. And then we see how much. So yeah, so the list is, there's no one list yet, but the blog posts list the project after each other. And in the text here, there's a template for a project proposal. In the forum by our community manager Richie, and he listed what a project proposal should include, for example.
Let's thank the speaker, of course.